It's the last day, the final day, and we have to cover some creational design patterns. That is what the syllabus says, right? So yeah, let's immediately get started. What comes to your mind when you hear something like creational pattern? Creational pattern, like what do you think? What would be its responsibility? So, there are so many design patterns out there. We have covered few important ones of them, but these design patterns are actually categorized in certain categories. So, certain patterns are called as behavioral patterns. Behavioral patterns are those which allow you to change behavior in the runtime to basically, let's say there is a method, the name of the method is func. So if you call func, then for certain types it behaves in one manner and for other types it behaves in different manner. Okay. But for the user of the class, all those types are coded against the same parent type. So the user would see that, yeah, the behavior is different. Yeah. Sometimes when I call this function, it behaves in one way. Sometimes it behaves in another way. By the way, which design patterns comes to your mind as I say these things? The design pattern of day one, what was it? Strategy design pattern, isn't it? So strategy design pattern allows you to configure or to get to see different strategies in the runtime, right? So strategy design pattern can fall into the category of behavioral pattern. Now, the category we are going to talk about today is creational pattern. So creational pattern has got to do with object creation. Okay. So all of us, if we are using object-oriented programming, we write a lot of code where we are required to create objects. Okay. Now, if you create objects, then the question that might come to your head is that, hey, what's the big deal about creating an object? I just have to do new of a class and then I'll get an object, right? So why do we need a design pattern for that? So this is a very genuine question that you should have in your head. So for that, we will take an illustration. Let's say you have a random class. The name of that class is, let's call it person. So there is a class called as person. Now, person will have several attributes. So if you talk about a person, he'll have his name. Okay. The person will also have some age. The person will also have some gender, which could be male, female, whatever. Okay. The person will also have, let's say, what else are the attributes of person? Let's say some ID. Every person has an integer ID, so something like this. Several attributes will be there for a person, isn't it? So I have just listed down 4 attributes, but if you look at your Facebook profile or Instagram profile, then for each profile, there are so many fields out there, like your educational background, your address, your hobbies, your interests, your relationship status, and so many things, right? Okay. Now, the question that I want to ask is, if you have to create the object of this person, then of course you will have to call the constructor, right? So I'm going to declare a public constructor called as person. Now, if I want to create an object of this person, I know that these are the attributes, right? So I would want to send in these attributes. So the easiest thing is that you add all these things inside the constructor, and then everything looks cool, right? But do you see one thing? I told you that this person can have multiple attributes. There can be 10, 15, 20 different attributes apart from these 4. So in that case, don't you think that this particular part of the constructor, which is receiving the arguments, will be extremely bulky because there will be so many arguments that will be taking. Don't you think so? Yes or no? Yeah. Okay. So this is the first thing that makes us feel overwhelmed about object creation. That if we have a class that has so many attributes inside it. Let's call that class as a humongous class, which has so many attributes inside it. Then it means that the constructor is going to be very bulky. The constructor will will be receiving in lot many arguments and setting those arguments to the instance variables. Okay, not just this much, it'll create a lot of confusion at the side of client also. So let's say somebody is using this. Okay, somebody is using that person class. Let's say I want to create an object of person. So what would I do? I would say new person. Now, as I do this thing, I'll have to remember the order in which these variables are to be passed. I'll have to remember that, hey, the first variable is name, the second variable is age, the third variable is gender, and the fourth variable is ID. I can't pass them in any order of my choice. It is not up to me. I'll have to pass them in this order only. So see, there are two basic problems, common sense based problem. The first problem is that it is going to be bulky. And the second problem is that the clients will have to, take care of the ordering in what order the data is to be passed. If you just have a constructor which takes one variable or two variable, or let's say at max three variables, it's okay. Okay, because till three, there are not so many reorderings. 3 factorial is only 6. But as you go on to 4 or more than 4, then 4 factorial or any factorial greater than 4 is so much. So you mentally can't remember all those orderings and reorderings. So that is a basic problem which is going to happen when you have a class that has so many attributes. Basically, when you have a humongous class like this. Okay. So this is one problem, but now you can use your common sense to think of some more problems that might arise with the use of these humongous classes. So come on, tell me, what are the other problems that you feel may also be there? We are not talking about solution. We are not interested in talking about solution at this point of time. We will first gather all the problems and then we will solve them all together. No worries, even if you feel that the problem that you feel might look very trivial, that's okay. Let's just share. We'll see. There can be different types of constructors. Okay. So what Manisha is saying that is arising from the fact that not all these variables will be mandatory. I mean, not all these fields will be mandatory. See, when you create your profile on Facebook, there are so many fields, but not all of them are mandatory. Most of them are optional and only few of them are mandatory, right? So in that case, does it make sense to have a constructor like this? Let's say for a person, we only have ID and name as the mandatory field. If only ID and name are mandatory field, in that case, whenever you create an object of person, you would want to pass in the name. Let's say the name is Shubham. Okay. And the remaining two fields, I am passing them as null. And the final field is ID. Let's say the ID is 101. Now, do you see the problem over here is that I have to forcefully pass so many null values. And why do I have to pass those null values? I have to pass those because they are mandatory arguments of my constructor. Now, it is a bad experience at client side because client is being forced to pass some data that it does not want to pass. The client is only interested in passing the name and ID, but the design of your constructor is such that it is forcing the person to pass other fields as well. Null only, but yeah, it is forcing the client to do that. It gives rise to one fact that different clients might have different requirements while creating an instance of person. So let's say a client wants to initialize by passing name, ID, and age only. That client does not know gender, so it will pass gender as null. Okay. Now let's say there is some other client who wants to initialize by passing name, ID, and gender only. It does not have age. And now let's say there is some other client who wants to pass name, age, gender, and ID. So basically, in order to resolve this problem, one thing that might have come to your head is let's create so many different kinds of constructors. So let's create a constructor person. which just takes the mandatory fields that are name and ID. And then we will simply initialize these two fields only. We will say this dot name is equals to the past name, and this dot ID is equals to the past ID. It makes sense. Similarly, in order to take care of those clients who want to pass name, ID, and age, you might want to create another constructor that takes in name, ID, and age. In order to take care of another client who passes name, gender, and ID, you would need another constructor. Is this a scalable solution? Do you feel that this is the way in which we should be taking care of things? No, right? Why no? Tell me. Does it sound something like a combinatorial explosion only? Because if there are n different attributes, then there will be 2 power n different combinations of these attributes. So you might want to, would you actually like to write constructor for each of them? The answer is no. That is really, really going to be a very bad solution. So this brute force solution is not the way out. We are not going to adopt this. So suggest me something better. What better can be done? Use of setters for setting values. Great. How many of you agree with that? What Shubham has mentioned. And another suggestion is something similar to decorator can be used in creation of object. Okay, we'll see that also. The most basic thing over here is to use setter for setting the values. So what Shubham is trying to say is that, hey, let's get rid of these many extra constructors that we have created. This is not a scalable solution. Let's get rid of this line also for now, because this is not how we want to create our objects. We want to be much smarter than this. So is saying that, inside the constructor, let's only and only pass the required fields. We know that the required fields are name and ID. So let's only pass them for now. And all those fields that are not required fields, that are not mandatory, do not pass them in constructor, write a setter for them. So if I want to write a setter for them, I have to first remove this final keyword. Do you see why I have to remove this final keyword? Because when an object is created, and let's say you have not initialized certain fields, then their values are null. They are automatically assigned to null. And if they are assigned to null, you cannot change them later. Final means that once you have initialized ID to something, once you have initialized this ID to 101, you can't change it. Okay, that was the thing with final. But now there are certain variables that you are not setting during construction phase, because you're not setting, so they are being initialized to null. Now you want to override that null value to something else. To do that, you have to remove that final keyword. It's a very important thing to be kept in mind. You asked me to introduce a setter, but because of introduction of that setter, I had to remove the final field from here. But do you understand why I had to remove it? Did everyone understand this thing? Yes or no? Okay. I'll come back to this. This is a very important, a very critical thing that we have done. Might not feel like that now, but it is. So, okay, for now, I would say that let's say we have a public void method called as set age. So set age method takes an age which is passed to it, and it simply does this dot age equals to age. That's it. Similarly, we can have another method, public void set gender. So set gender will take a character G, and it would say this dot gender is equals to G. Okay. Makes a lot of sense, isn't it? Now this kind of looks like much better solution than the solution that we had before, in which we were writing so many constructors, isn't it? How many of you find it as a much better solution than the previous solution? You can say yes or no, whatever. Yeah. So now you can imagine if somebody has to create a person, then what he can do is he can do new of person and pass in the required fields. Let's say the name is Ram and ID is 101. Okay. So these are the mandatory fields that I have passed. From this, I have got a particular person. Let's call that person as P for now. Okay. And now you can Now, if you want to set other fields, you can do p dot set age, and you can say that age is, let's say 9, and If you want to set the other thing, you can set that also. Okay, so this definitely looks like a better solution. But what is wrong with it? Can it risk us in one way or the other? To give you a hint, in order to introduce these setters, I had to do one change. Do you remember what that change was? That change was to remove the final keyword from here. Yeah. So Dinesh is saying that gender can again be reset. That is what the problem is. So I'll give a much more generic perspective on this. So have you guys seen that in the industry code, which is well written and maintained, people try to write immutable classes. What I mean by immutable classes is they try to keep everything as final. Why do they try to keep everything as final? They try to keep everything as final in order to ensure that the data does not get corrupted. Like he mentioned that somebody can change the gender of a person from male to female or female to male in the runtime. And that is something that we would not want. We would want that during the object creation time, let's say we fetch these details from databases and initialize them to something. Now we might not want others or other threads of my system to be able to change these fields. So removing final means that your data is exposed and it can be set to any random value by the other threads. So that is one concern which is definitely there. Is it making some sense? Yes or no? Yeah. There is one more concern with it. If something is mutable, if something can be changed, like these fields can be changed, in that case, if there are multiple threads that are trying to change it, can there be some issues? What problem arises when multiple threads try to access a data and change it? What problem happens? You must have heard of it. Race conditions. Very good. Race conditions can happen. Let's say at a point of time, one thread is trying to add +1 to this age, and another thread is also trying to add +1 to this age. Then the overall effect that I would expect should be +2, but it is not necessary that +2 really happens. All these kind of nonsenses happens when there is a multi-threaded program. And in industries, you always have multi-threaded program. So it is always recommended that, hey, do not have anything as non-final. Because if you make anything as non-final, it can lead to unknown bugs creeping in. You will not even get a clue that how this age changed or how this gender changed. So the point that I'm trying to make is that if you have decided to keep a field as non-final, then you have to keep it in your mind that in future anything can happen to that field. So either you have to write your code in a thread safe manner, which is extremely hard thing to do. The easier thing is to keep everything as final. Is it making sense that why it is an important thing to either keep or remove final? Yeah. So of course, this setter based solution that we have created, it makes our design look much more elegant, but it involves a big trade-off, and we are not ready for that trade-off. So we will revert it. Okay. We don't want to live with it. We will revert it. Okay. So what else can then be done? You know, I have heard a lot of solution from different people. In that solution, people say that, hey, if there are 100 fields, ideally you would be passing 100 arguments here. So why not pass an object here? Let's just pass an object, and that object will have those fields inside it, right? So let's say there is an object O that we are passing. Now we can say this dot name is equals to object dot name, this dot ID is equals to object dot ID. So we may do something like this, but now the question is that, hey, how will you create that object? Because that object, the first thing that is required is that all the fields which are present in person should also be present in that object. And the same problem that you were encountering in creating an object of person, you will encounter in creating that particular object. So this also does not sound so evident, right? So basically, it does not make sense to create a separate class outside of this class where all those things are happening. So one thing that a lot of people do is they say that, hey, let's create an inner class and let's create that as inner static class. So we will have a public static class. And we are going to call it as builder for now. Okay. Public static class builder. See, if something is static, if anything is static, then you do not need the object to access that. So what I mean by that is you do not need an object of person to do p.builder. You can simply do person.builder. Why? Because this builder is static. Okay. So this is an important point to keep in mind, right? Okay. Now, if you take a look here, so inside this builder, what I can do is I can introduce all these fields, whatever fields were there, just copy them and let's paste them all here. Okay. And now let's remove final from here. So we are taking a risk for this class, but this class is going to be a temporary kind of class. This class is going to be, you will see when I use it. This is an inner class. We are just using it for the purpose of creating an object of person. Okay. So I have removed these final keywords from here. And now the first thing that needs to be here is a constructor. So we will have a public builder. Okay. So somebody calls constructor. Let's say we are doing nothing inside constructor. Initially, everything is initialized to null, 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 and null. Now I can have setters. Okay. So I can give these setter some names. I can give them the same name as the variable name for now, just to make things look intuitive. So let's say I have a public method called as name, and it takes a string name, and all that it does is this dot name equals to name. I'll do one interesting thing now. I'll make this function to return an instance of builder. So I would say the return type of this is going to be builder only. Okay. And for that to happen, I need to write one more line, which is return of this. Okay, now let's observe what I have done. There is a name method. This name method takes in the name which you want to set, and it sets that name. And after setting that name, it returns you the object of this builder. Now, when it returns you an object of this builder, what you can do is you can use that object to call another method. Because if you look at this method, this is not static. This is not a static method. So you need an object of this to perform an invocation here, right? Similarly, I can write several other methods. Let's say I write public builder and call it age. Now here we are taking int age, and we are setting that this dot age equals to age, and we are returning this. The same thing can be done with all the other fields, which are gender and ID. So this will be gender here. And here you will have ID. Okay. Now, if you look at it, do you see how things are going to happen? You see that this builder is a static class inside this person. So in order to call the constructor of this class, I do not need an object of person. I can simply do something like this. I can do something like person dot builder. Now, when I do person dot builder, what happens? What will this thing return to me? It will return me an object of that builder class that I just wrote, right? And now once you have an object of this builder class, then using that object, you can easily call the method like name, the method like age, and all such things. Okay, cool. So let's go back to that. When you look at this person.builder, it's actually a constructor. And in order to invoke this constructor, you'll be using a new keyword, right? Now, what is the return type of new of person.builder? The return type of this is an object of builder. Now you can use that object to call name method and pass the name here. And now, what is the return type of this name? What is the return type of this name? The return type is object of the builder itself. So now again, you can use a dot operator to call age method. Okay. So now you can do, if you go back to this, you can now do dot age, and you can pass whatever the age is. Okay. And then you can again do a dot, and you can set gender, and you can pass whatever the gender is, male. Again, you can do a dot if you want to do. So basically, do you see, this is a much more intuitive way of creating the object, where you have done person.builder. And so far, if you take a look, till this point, from beginning till ending, what has happened? We right now have an object of builder at our disposal, whose fields are Ram, which is the name, 10, which is the age, and M, which is the gender. Okay, so this way we have initialized these things. Now the question is that, hey, so far we just have an object of builder, but what we want is we want an object of person. So for that, we can have a final method. We can call that method as build. And this method will somehow be responsible for giving us an object of person. Okay, so when I call this build method, all that it will do is it will return us new of person. So it will invoke new of person and it will pass this to that. Okay, so now when you look at the constructor of this person, I would say, hey, let go of all these things. I just need a builder here, builder B. And I would say this dot name is equals to B dot name. And I would say this dot ID is equals to B dot ID. And this dot whatever age is equals to B dot age. And finally, this dot gender is equals to B dot gender. Okay, now do you see what has happened? So now if I have to go back there, and let's say I just want to create a person with a name, age, and gender, then I can simply do this dot what build. When I do this dot build, what will happen? As a consequence of this, I'll get a person object with these fields initialized in them. Okay, so now you can see that. Let's remove it from here. So did you know the most important point? The most important point over here was that we created a separate class. The name of that separate class is builder. We intentionally kept it static. Why? Because we want to invoke its constructor without having the object of person, because the problem is to create the object of person. So if I have to create the object of person, I want to be able to do that only on static things, so that the object is not needed to make that call. And after that, what I did, when I invoked this builder, then I got an object of this builder class. Now using that object, I invoked this name. So what it did, it set name field inside that object and then returned me that object. Because it returned me that object, I used that to call age, and then use that to call gender, and then I could have used that to call ID, whatever I want. So that is the basic thing that I have done. So you can see that new of person dot builder gives us a builder object B, in which all the fields are null. This much part of the code puts name field inside that object as Ram. This much part of the code further puts age field as 10. This much part of the code further puts gender field as M. And this entire part of code, this is where the actual beauty happens in this build method. It transports that builder object inside the constructor of person. And now what it does is it copies that data as it is into its fields. So that is what has got happened. And this looks like a much better solution, because now if you have this kind of person class, then your client can create a person with whatever fields that they like. So if I go back to this, somebody, let's say, wants to create a new of person, then he would first have to do new of person dot builder. And then let's say he just wants to pass ID. So he can pass the ID as 109 and then simply say build. So as a consequence of this, what will happen? We will get a person object in which only ID is there and everything else is null. So in this solution, if you take a look, what has happened is that first of all, clients have the flexibility to pass around the fields of their choice. And there is no confusion. They know that name method takes name, gender method takes gender. And most important thing is that the fields of my person is final. So there will be no race condition, no issues because of the use of multiple threads. And this is what is builder pattern for you. Is that making sense? How many of you are getting a hang of builder pattern and why this builder pattern? You can just say yes or no. There were so many things here. If you just reiterate the things that I spoke right since the beginning, you'd find it out that the first thing was that if we have a humongous class which has so many fields inside it, then the constructor will be bulky. Okay. And if the constructor is going to be bulky, then clients at times might want to only initialize few fields. For that, you created so many different constructors. That was not the right choice. Then you used setters. When you use setters, the final had to be let gone off, which led to the thread issues and all. So we came up with this builder pattern, which addresses all these issues. Okay. So there are certain questions. Question from Jagdeep is why we have not used separate class outside person. There is no use of doing that because usually whenever you create an outside class, then it is perceived as an individual entity in itself, and people might want to, create an object of it. Here, because it's an inner static class, so the object of this are temporary, they are short-lived. Do you see that? This builder is specific to person. I mean, you can see if you take a look at this code, it lives from here to here. The builder object lives from here to here. But the moment this call is made, it sacrifices its life to create a person object. How shall we restrict creation of object with mandatory fields? That's a very good question. Yeah, how can that be done? So we discussed that person, let's say there is only one mandatory field in person and that is ID, okay? Now, if a client wants, that client might just go ahead and do something like this. So the client is being allowed to create a person without any ID, which is bad, isn't it? It's bad. So how do you prevent somebody from creating an object without injecting the mandatory fields inside it? There's a very simple solution to it. I want you guys to tell me. Meanwhile, Shant has a question. Does it mean classes with many fields should use this approach? Yes, of course. Classes with many fields in which certain fields are optional, certain fields are mandatory, must use this approach. You know what we can do is, we can say that, hey, inside the builder constructor, we will definitely take the mandatory field int ID. And here itself, we will do this dot ID equals to ID. Now that we have done this, we no longer require this method. So we can just remove it from here. So do you see? The only change that will happen now, and that must also happen, is that now when I call the builder constructor, I definitely will have to pass an ID. I definitely will have to pass an ID. Okay. If you do not pass that ID, then things will not be allowed. So all that we have done is inside the builder constructor of your person class, inside this builder constructor, we have taken the mandatory arguments. So if you have certain mandatory arguments, please put them in the builder constructor itself so that the client is forced to pass it. Is it making sense to everyone? Yes or no? A very simple solution, isn't it? Okay. One more thing, there are certain fields on top of which you may want validation. And it's very important to have those validations in place. So would you allow something like this? Would you allow somebody to pass a negative age? Of course, no, because that's a corrupt data. So in this case, you may simply want to throw an exception, invalid age, something like this. Okay. So all those kind of validations can also be put inside these methods of builder before transporting this data to the constructor of person. Okay. If there are certain other logics also, like, so at times object, if there is a very humongous object, at times the object creation could be tricky. Let's say there is a field called as college name. Okay. There is a field called as college name. And then there is another field called as degree. So let's say these are the two fields inside person. Now, if degree field is set inside the object, you would definitely want college name also to be set, isn't it? Yes or no? So these kind of requirements can be there, that if a certain field is set, then certain other field must also be set for that. So either none of them should be set or both of them should be set. So all those validations can be done here in the constructor of person, where you can check if whatever are the contents of this builder, if b dot college name is not null and b dot degree is not null, then only this is a safe scenario for you. If one of them is null and the other is non-null, then this is not a safe scenario. So all those validations can also be done over here. Can we do the validation in build function instead? Yes, that will be an even better idea. So you can do all those validations inside the build method itself, so that whatever you are passing to the constructor is a sane builder, is a sane data that you are passing. And you can throw the exception from here itself if it happens. Does it make sense? So, my point was to make you realize this thing, that object creation, as long as you're just a student, you are learning basic oops for just learning purpose. These things are very basic, but as you get into industry, as you start writing code for organizations, there usually the classes are humongous, the objects are all humongous. So in that case, you have to take care of all these things. Okay. So this was a creational pattern for you. Anyone who would like to summarize everything that we have talked about so far? Yeah. So let's start in this manner. When do you realize the need of builder pattern? When you have a humongous class. Okay. And what is the brute force solution to it? The brute force solution is that you create a constructor which takes in all the fields. Now we want to do better. So how do we do better? We do it by writing so many different kinds of constructors, but that leads to combinatorial explosion. So what is an even better solution? Even better solution is that you create setters. When you create setters, then you risk the immutability. So we finally come back to builder pattern. However, when we come back to builder pattern, we realize that certain fields can be mandatory. Those fields that are mandatory can be passed inside the constructor of the builder directly. Okay, we also realize that certain fields can be insane data. That insane data needs to be checked and an exception needs to be thrown. Okay, we also realize that there can be some validation for combination of data. All that can be done inside the build method itself before passing that data to the constructor. So this is the entire summary of builder pattern. If you understand all these things, then you truly understand builder pattern. Otherwise, I have seen a lot of people in industry using builder patterns without having a very deep understanding of all these things. Because usually, like once I found it out in an interview that a candidate was asked to talk about builder pattern, the candidate had used builder pattern. I mean, he or she could write classes like this, but they did not understand that, hey, what would go wrong if I simply have setters? So this is important, right? Okay, cool. So after this creational pattern, there is one more creational pattern that you guys should consider going through, and that is called as factory pattern. That is much easier than this. Factory pattern is usually about centralizing the responsibility of object creation. Okay, so I'll talk about it very quickly so that all of you get an idea of it. And after that, I'll tell you which videos you can probably refer to get a hold of that, get an understanding of that. So if you remember, when I had talked about strategy pattern, I had said that you have a super type. Let's say there is a super type called as reader, and this reader for now has a very simple method inside it, void read. Now let's say you have different kinds of readers. You have a reader called as console reader that implements reader interface. Okay, and so console reader reads from the console. And then let's say you have another kind of reader that is drive reader. So let's say this drive reader reads from your Google Drive. It has the functionalities to do so. It has the functionalities to talk to Google. This also basically implements the reader interface only and its method. Similarly, you can have 10, 15 different kind of readers, as many as you want. Now, in several parts of your code, you might want to create their object. So somewhere you might say that, hey, I want a drive reader. I want an instance of drive reader. Somewhere you might say, I want an instance of console reader. So let's say you're doing that on the basis of something. So let's say there is a string S. Let's say for now, this is your input. S is your input. It is being sent to you from somewhere. Now you'd say that, hey, if S dot equals console, in that case, you would say that, hey, I would go ahead by creating an instance of console reader. Okay. Else if S dot equals something else, let's say drive. So in that case, I'll create an instance of drive reader. Now, you can already see that a chain of else if condition is going to arise. And this particular chain of else if will be replicated everywhere in your code base. I mean, wherever you have a string S, and based on that string, you want to figure out which reader is needed to be created, you will end up creating this else if chain. And you will have it in, let's say there are 20 places, 20 classes in your code base, which has to do with something like this, then they'll do all sorts of things. Is it making sense? Yes or no? So this is something which is bad. So factory pattern, what it says is, it says that we want to centralize this responsibility of object creation. So for doing that, what one can simply do is, we can say that, hey, we will have a simple class called as reader factory. Okay. Now reader factory is a class, and let's say it has a simple static method for now. And this static method will return a reader. I'll call it get reader. Now it takes a string S, and then let's say it initially initializes reader R to something called as null. Now it has if else condition. So if it sees that S dot equals console, in this case, it says that R is equals to new of console reader. Else if it sees that S dot equals drive, then it does something like R equals to new of drive reader. Okay. There would be so many other else if chains also. And finally, it can just return R. Do you see the power of this method? The power of this method is that now if you have got 100 classes, all those 100 classes will not contain these if else logic inside them. They will simply call get reader, pass the string S, and get the instance of reader that they wanted, whether it was a console reader or a drive reader. So what we have done here is we have centralized the object creation logic. And it's great, isn't it? Because imagine tomorrow if you introduce another kind of reader, and if you had this if else condition split everywhere in your code base, then you had to write one more else if in all those 100 classes. But here you just have to add it here in this method, and everything else will work like a charm. So this is factory pattern for you, which centralizes the object creation logic. Is it making some sense to you? We have covered it pretty quickly, but did it give you some 10-15% clue at least, or 20-25% clue of what factory pattern is all about? So on your dashboard, there are two videos. The first one is on factory pattern. The second one is on abstract factory pattern. Today is Saturday, tomorrow is Sunday. So take some time out and go through that. And also revise builder pattern. And then that will be, I think, super helpful for you. Cool then. So if there are any questions, then you can ask. By the way, what I have to say is that given that you feel that you have been pumped or you have been calibrated to learn low-level design, you should now not stop. Because the thing with these topics is they are extremely, extremely practical in nature. So if you learn it for a week or so and then leave it, within another month, you will most likely forget it. So if you have started it, the next logical step for you should be to cover the case studies associated with it, and also the other design patterns that are important. Yesterday, I also asked you to go through design principles. So if you did not get time, please go through those, because that is a different thing. There are 5 design principles, solid principles. We need to know what they are, because all the design pattern is motivated from a combination of those. How many of you feel like the industry that you currently work in, the knowledge of design pattern will help you write better code there? Do you feel like that? I personally feel that it has got a lot to do with promotions. Like, I'm not so sure about all the companies, but especially when I was at Amazon, I mean, promotions used to be very much deeply tied to how neatly designed code you have written. So people who were the, let's say the bar raisers of promotion, they used to go through the code reviews, and they used to find out that, yeah, here you have used this pattern, there you have used this, just check for code redundancy and all. They used to give a certain score. It was very, very essential for people like SD1 and SD2. When you become SD3, then there are so many other things that also matter. But especially for early stage promotion, where you are, if let's say you have 5 to 7 years of experience or under that, these things matter a lot. And even when you become SD3, then you have to give these design inputs to SD1s, people who join your industry. You have to tell them that, yeah, just explore this design, because freshers don't know anything, like they just know a language. So you have to be an expert of these things, then only you can drive them better, then only you can produce a better quality code. So it's like, it's a very, I would say, a technical skill that sets good tech leads apart from the not so good ones. I mean, yeah, that's what my personal experience is. Yeah, I think you should definitely encourage everyone around you also. I mean, be it your juniors or your peers, to explore and learn these things. But they are not, so I would say they are not very computationally intensive things like DS, Algo, or maths. So they can be learned even by giving 1 hour each day before sleeping or over weekends. But they have a high return. That is what I'm saying. High return in terms of, you just interview with companies and you display that you are amazing at these skills, they will consider you as an amazing asset. That I'm 100% sure. So it's a skill that is, worth toiling on, worth giving a lot of time. Okay. I think great. Then I mean, I'm always reachable. I'm very much available. If you need me for anything, feel free to ping, and we can connect and talk more about it. I hope you guys were able to make some good use of these 5 to 7 hours. And all the best then. Great. Bye everyone, and take care.